Hello, everybody. I want to do a program and demonstrate today the close relationship that arrays have with pointers. And I'm going to use just this simple program to begin with, which has an array of 10 integer values that I'm calling odd, and I've initialized it to the odd integers that you see here. And I've got some other things declared, just some integer values I might want to use in a loop coming up. And then I have a pointer, even, which is a pointer to an integer. And I've got another pointer called pointer1, which is a pointer to an integer as well. Now, if I want to be complete here, I really should set these to null pointer. And that's just, you should initialize things when you declare them. And it's also possible that Visual Studio would give me an error if I don't do that. So I am going to cover my bases there, so make sure that that's done. Let's begin very slowly. We have the array odd, and you know that we can print out the value of an index using an index of any element of an array. So if I paste in this statement, then this will just print out odd index 0, so there's the string constant, and then it'll print out the actual value over here, which should be 1. So we're starting out slowly, so let's actually compile the program and run it. So to no one's surprise, then we see that we print out the odd string here, and then its value is equal to 1. So in the examples I do in this program, I'm going to try to print things out in a kind of a tabular form. So I'm typically going to use this kind of thing where I'll have a string that I print out indicating what I'm going to print, and then I'll actually print out the thing itself over here. Now, what would happen if we just printed out odd, but we didn't use the brackets? Have you ever tried to do that? Well, here's what I mean. Let's paste in this line of code. And here, I'm going to print out odd equals, but I'm not going to use the square brackets. Now over here, you can see I'm using the, whatever this thing turns out to be, I'm going to convert it to an integer. So now, let's compile the program and see what we get this time. So let's look at the output. And this time, the second line is going to give us odd is equal to and a very large number. Now, that number looks like an address to me. And maybe the reason that it looks like an address to me is because I do know that it is an address. So have you ever tried just to print out the name of an array with no brackets? If you do, then you get the address of the first element of the array. We also know that we can get the address of any element of an array or for any variable by using the address operator. So let's add that to our list of simple output statements to see what we get. So let's use the address operator. So here's the line of code we can use to do that. So I'm going to print out odd, and let's put the ampersand here because that's what I'm really printing out. So let's add the ampersand right there because I want to get the address of index 0 of the array odd. Now this is going to be an address. It's okay to do that. This is just a single integer value that's stored at some location. So I can get the address of that location. Then, since I don't want to see the hexadecimal, I want to convert that to an integer. So then we can see if this address at 0 is the same thing as the address we get here. So now let's compile and run the program. We'll bring over the output, and sure enough, if we print out the address of odd index number 0, then we get the same address as if we print out just the name of the array itself without any square brackets. So this shows you then that if you reference the name of an array, if you have an array and you just use the name, that's the address of the first element. How about that? So that means, in effect, that the address, the array, contains an address. We have seen already that a pointer is a special variable that contains a memory address. Then this thing must be a pointer. Well, If it's a pointer, then perhaps we can dereference it. And if we dereference it, what do we get? Well, let's add that line of code in and let's see what comes out. So we'll put that line of code in here and I'll go get it. So now let's dereference that address. Okay, so if we know that odd is an address, then we can dereference it, and then we should be able to get to the first value of that array. Let's compile the program and run it. Now we'll bring in the output, and here we go, there it is. So now let's examine what we have. We print out the value of index 0. Okay, so that turns out to be 1. So we have that here. Then the next thing we do, we just print out odd, and we change it from a hexadecimal value to a base 10 number using this type conversion, and we get the address. Then if we want to print out the address of the first element, then we can do that with the third line using the address operator, ampersand, and we can see that the address of index 0 of the array odd is the very same thing we get if we print out odd by itself. That being shown, then we have deduced that the first element of the array, it must be a pointer, or that is the array itself, the name of the array. It must be a pointer. And if it's a pointer, we can dereference it. If we dereference it, then we get the value 1. So you can tell already that pointers and arrays now, they have a very close relationship. In fact, you can use either notation that you want. And that's what I'm going to show here in this video. So an array has the variable that is the name of the array just contains the address of the first element of the array. Now, if you think about how we pass arrays to functions, this now makes sense. Whenever we call a function with an array, we don't use any square brackets. Remember that? We just use the name of the array. The name of the array just happens to be the address of the first element of the array. So we're doing a call by reference, and we're sending in the address of the array. We don't need to use any special notation other than that. Now, if we can do this for the first element of the array, then let's try to do it with some other elements of the array. So I'm going to try a couple of things here. Let me just copy this first line. So I'm going to copy that, and we'll paste it down here. And we'll print that out, and let's change this, say, to index number 1. So that would give us the value 3. So we'll print out index 1. So that should give us a value of 3. Now, everybody knows how to do that. You can index through an array just by changing the index from 0 up to 9 in this case and get all the elements. Well, what if we want to use the pointer notation for that? I can paste in this one, and I'm going to change it up just a little bit here. I'm going to take odd, which is the address of the first element, I'm going to add 1 to it. Okay, so let's close the parentheses to that. And I'll do the same thing over here. Let's take the odd, put a parentheses there, and then let's add 1 in here, close the parentheses, and then let's print out what we get. Let's fix the comma there first. It should have been a space. All right, so what I'm going to try to do here is I'm going to take the address of the array, I'm going to add 1 to it, and then I'm going to dereference it. So let's see what happens now. So I'll bring over the output window. And let's look at the output. So this time, when I print out odd index number 1, I get 3, which is, that's what we have up there. But if I use this notation, I also get 3. So what this is doing is it's taking that beginning address, and we're doing some pointer arithmetic now. So if I have the beginning address and I want to add something to that, then I can. What this is doing, since odd is a type integer, it's going to add 4 bytes, and then I will dereference that, and I'll get the value 3. So we have to do this inside the parentheses. We have to take the beginning address of the array, and then we add whatever offset we want, and then we dereference the result. So we have to have the parentheses. So now we could continue to go through this array, and we could print out other values as well. So let's do one more before we move on to something a little different here. So let's look at outputting the next index. So let's print out odd 2 using the regular bracket notation. And let's also do it with our pointer notation. So if we want to get to the third element, that is, index 0, 1, and 2, that's the third element. So I will take the beginning address and I will add 2. Then I'm going to dereference it. I probably should do it over here since that's the string on that side. But I'm just going to add 2. So the arithmetic shows up again. I take the beginning address, I add 2, which is 2 times 4 bytes, gives me 8 bytes. So that moves it that far ahead. Then that resulting address, whatever that is, I dereference it, and I should see the output value for index 2, which is going to be 5. All right, so you can step through an array by using pointer notation as well as you can with the bracket notation. So let's see this final result before we print out the rest of the elements of the array. So now we can see that we can print out index number 2 using the square bracket notation. We get 5. Or we can use the pointer notation where we take the base address, we add 2, then we dereference it, and we also get the value 5. So this shows you then the relationship between pointers and arrays. It would take a little bit of time and copying and pasting to print out the entire array. So let's see if we can do it a little bit more efficiently. So what I want to do is to move ahead, and I want to print out the array using the bracket notation, and then I'm going to print it out using this pointer notation. So moving down, let's take out that system pause. We don't want to stop up there. And I'm now going to print to the screen, print out odd with the bracket notation. So this is the standard way that you would print out an array. So let's just paste the code here. And this is not anything new. You've seen this already when we talked about arrays. But the way I'm printing it out, I want it to be a nice table. So we'll have, K goes 0 up to 9, K++ in the for loop. And I'm going to print out this string first. I'm going to print out the name of the array, and I'll print out the left-hand square bracket. Then I want to print out the index itself, K. Okay, so K is going to go 0 through 9, so I'm going to print that out. Then I'm going to print out the closing right side bracket next. Then I'm going to print out the actual contents of the array using the index K. And then I'm going to print out its address. So this is a pretty wide field here for the address because it's a big number. So I'm going to take the address of every element that's in the array, and I'm going to print that out. So this is going to generate a table then showing us all of the elements of the array odd. So let's go ahead and run the program with this. So here's the output, and you can see the table that we get. All right, so I didn't mention it, but I've got a cout statement at the top where I'm going to print out the variable and the contents and the address, just as I've done in previous videos. So let's go ahead and look at that table. So our variable now is going to be all of the elements of the array odd. So you see them here on the left-hand side. And the contents will be what's contained in each of those locations. And those are just the integers, 1 through 19, the odd numbers. And now I've also printed out the addresses where they're stored. So you can see now that these are going to be stored one after another. There is no space in between. So that's an important thing to remember for an array. When you declare an array of numbers, you can be assured that each element of the array is going to be stored next to the previous one. They're all contiguous. So we can see that here. Okay, the first one is address 4. We have 4 bytes for each one, so that one's 8. Then we'd have 12, 16, and so on. So these are consecutive memory locations, and that's one reason I wanted to print this out, to show you that with an array you do always get that, and the last one's 40. If you have just ordinary variables that you're printing out, then they are not going to be adjacent to each other in memory. Okay, well, we've printed out this just with our standard old-fashioned square bracket notation. Now let's do the same thing, but let's use our pointer notation. So I have the for loop already set up. It's the same one as that we just did, but this time I'm going to print out pointer as my column header over here. We're going to use pointers. And we'll still have the contents, so we'll still have the address. So let's add the code here so that we can use the pointer notation to print out the array odd. We'll put the code in the loop, and now let's go through it. So I'm going to use the pointer notation. So recall, just up above, I had to take the beginning address, which was the name of the array, and then we added some offset to it, and then we did the dereferencing. So if we're going to use pointer notation to print out all the contents of the array odd, then we are going to do the same thing, but we're going to offset with the index k instead. So I'm going to print out, to begin with, this pointer notation. I'll print out the asterisk and parentheses odd plus and close that with a double quote. Then I'll print out the value k once again. Following the k, I'll print out the closing parentheses. Then we will actually print out the thing here using pointer notation. So we're going to take the address odd, we'll add whatever k is to that, then we'll dereference that entire address. Then we will print that out. So that will give us the contents of the array. And then I am going to print out the address. Now, I don't have an address operator over here because odd itself is an address. And I'm going to add something to that that will still give me an address each time. And then I'll convert that from hexadecimal to integer, which is printed out as a base 10 number by default. Okay, so notice what's going on here. Odd is the address of the first element. If I add k to it, then it gives me the address of the kth element of the array odd. So now let's generate this table. So now we have the results, and you can see the table now with pointer notation. We add the value k to the address odd each time, so k goes 0 through 9, so you see that on the left-hand side. And of course, we just add that to the base address and then dereference it. So this is using pointer notation. And here are the contents of the array. So that's great, right? So now we have the same information printed out using pointer notation. And here are the addresses of the elements. So let's check to see if those addresses are the same that we got previously when we used the bracket notation. And they are, right? 13629244. 13629244. So we do get exactly the same output as far as the contents are concerned and the addresses are concerned. But now you have two techniques that you can use to index into an array. We can use the square bracket notation and you can use the pointer notation. You may be wondering why you would ever want to use this pointer notation, because it's more complicated than just using the square brackets. Well, just give me some time with that and I'll show you the value of using this as we proceed through this series of videos about pointers. But for now, just know that this notation is available. You can use the pointer notation as well as the square bracket notation. Okay, so there's the pointer notation, there's the square bracket notation. Now, let's move on and look at some other things we can do with this. If you scroll down to the next example, then we're going to print out the array odd with another pointer notation. So I'm going to print out this time just two columns. I'm going to print out pointer 1, which I declared up here. Okay, so now I'm going to use that. So I declared pointer 1 up there. And I'm going to print out what its value is, and I'm going to print out what it points to. Now look at the for loop. With this sorry about the scrolling, but with the other for loops, we used our standard technique. K goes from 0 to 9, K++. Well, let's use the pointer in the for loop. So let's set pointer 1 equal to odd. Pointer 1 equal to odd. That means we're going to set pointer 1 to the beginning address of the array odd. How do we stop? Well, as long as pointer 1 is less than odd plus 10. So if our beginning value for odd, say, is 1,000, then we know that we're going to get 10 more words or 40 more bytes. So when we get to that address, then we want to stop. This is also showing you that you can compare addresses. So remember, we looked at that with the pointer arithmetic. So here's a pointer, and it starts out at index 0 for odd. And it keeps going until we get to odd plus 10. So that's an address, and this is an address as well. So it's okay to compare them. And we are going to use our pointer arithmetic here in terms of the increment operator. So this little for loop, it starts at odd, it goes until we get to odd plus 10, and we increment the pointer each time. So the pointer is being incremented. Then that means we can dereference that pointer and we can print out the elements of the array. So I'll paste that line of code in here, and let's look at the output. I'm going to print out the pointer itself, right? It starts with the address of odd. Then I'm going to print out what it points to, and that's going to give us the elements of the array. So now let's run this example. Now we can look at the output, and here it is. So pointer 1 starts with this address. So let's go check that address to make sure it's at the beginning of odd. And if we look up here, okay, index number 0, 1625, 1496. So that is the first element. And we can go all the way back up here, and we know that odd is that same address, right? So we are at the beginning of the array, and pointer 1 is set to that beginning address. When I dereference it, I get the value 1. Then as we go through the loop, I increment that address by 1, and that is 4 bytes because it's an integer, and that takes 4 bytes. So we go up 4 bytes to 500 right there. I dereference that, I get the value 3. When I increment again, look down here, we're doing pointer 1 plus plus. When I increment again, this goes to 4. I dereference the new address, and I get 5. And this continues all the way through the array. So here is a kind of a shorthand method that we can use to step through an array that's a little bit cleaner. It doesn't involve the parentheses and the dereferencing and all that, but it gives us the same thing. So that's a different approach that you could take. You can actually use a different pointer, initialize it to the beginning of the array, and then increment it as you go through the loop, then just dereference it to get the elements that it's pointing to. Maybe the hard part here is what do you put here to stop, and you have to offset from odd because you don't know the address until the program is run. So that would be assigned by the operating system. We don't know what it is, but whatever it is, that plus 10 will be the end of our array. Now, that's a neat thing to do, but can we do it without having to use this pointer 1 at all? I mean, can't we just use odd? Odd's a pointer. It points to the first element of the array, so why did I have to make a copy of it here? Well, it turns out that we can't do that. So let me demonstrate that. In this example, I'm going to do it a little bit differently. I'm still going to use k. K goes from 0 up to 9k++. And I'm going to print out here the dereferenced address odd, and that's going to point to the first element. Then I should be able to just increment odd here. So I could do odd plus plus, and that would get me to the next element of the array. That's the next address. So this plus plus operation, we have seen that that works just fine. It worked up here. But when I use it down here, if I want to try to increment odd to get to the next address, I have the red underscore. So that is not a modifiable value. And the reason for that is that if I change the address odd, then how would I ever get back to the beginning of the array? If I change that address, then I'm going to mess up my ability to ever get back to this. Now, maybe I could figure that out, maybe I could keep track of it somehow, but the operating system isn't going to trust me to do that. So it's going to say, no, I'm not going to let you change the beginning address of the array. So this thing it's protected by the operating system. So we cannot do that. So that's why we had to make a copy of the pointer up here. The original pointer odd, the initial value of the array, initial address, cannot be changed, but I can copy it over into a different pointer. Then it's okay if I change that pointer because I'm not changing odd at all. So that works fine, but remember, you cannot change the address. And I'll just put a little comment here to that effect, right? So we'll put that in. And that's one thing we just have to remember. We have to play by the rules, so we can't do that one. All right. Now, this video is up to about 25 minutes now, and I've got another set of examples I want to go through, but I don't want to take up or make this video twice as long as it is. So I'm going to call this part 1 of the bracket versus pointer notation, and I'm going to follow it up with another video that's going to use a dynamic array. So we'll stop this video here.